Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amizah Abdul Salam from Dep50072, nombor matrix 09 Dep19F1056. Today I would like to explain about my essay 2. So number 1, the question is, pulse radar is a radar device that emits short and powerful pulse and in the silent period receive the echo signal. With a suitable diagram, explain how pulse radar work related to PRF and PRT, average power, and describe the factor that affect echo signal. So this is the diagram of PRF and PRT. So this is the wave of PRF. So this is resting time, and this continuing of the wave, which carry wave. So PRF is within the wave, but PRT is through the wave and resting time. So average power is this is the average power is the average power diagram, which is they have the first part is peak power, the second part is power width, and they have average power on the middle, which is from the power width through the next pulse. So this is the power. The average power is called time, which is PRT. So PRT is go through the average power. Okay, so next, the factor that affect echo. First, the echo signal from radar are reflected from all object in path. Second, the reflected signal is strong from metal and from large, close and flat object. Okay, second question is clutter, noise, and jamming are type of radar interference that affect the radar performance and PPI radar display. Explain this type of interference and visualize the interference. Your answer must be supported by the PPI radar display figure that show all the interference. So this is the figure. So from 0 degree to 90 degree is noise jamming. Noise jamming is flood the radar with noise and therefore decrease the SWR. A powerful jams can hide the target completely. So the jammer in by 150 degree within the 40 miles. So noise is most in region with low signal level, such as the weak received echo signal in a radar receiver. The lower signal power of the desired signal, the more difficult to discern it from the noise. Lastly, the clutter. Clutter is described by any object that may generate unwanted radar echoes that may interfere with normal radar operation. Next, for question 3. The question 3 a K-band radar is used speed limit information of highway. The radar shown in figure below is used to determine velocity of an approaching vehicle using an 28 GHz microwave signal. It uses a 25 dBi gain antenna for both transmitting and receiving radar signal. The radar uses a transmitter with a power of 90 watt, which is applied to the antenna terminal. If the received power from the antenna is 0.3 per watt and R is 1.3 km, calculate the radar across section of the vehicle. Ignoring the losses, including free space loss in the calculation, determine the frequency differences between the transmit signal and receive signal. If the vehicle is travelling at 130 km per explain Doppler effect related to this situation. So at first we must know the PT, power transmit is 90 watt, and power receiver is antenna 0.3 power watt. The distance is 1.3 km. So we must use the formula is PR equal PT plus PT GT GR lambda 2 per 4 pi power 3 R4. So it will get for the frequency difference between the transmit signal and receive signal is 1.9. So for the velocity, for the V, we can get 72.22 Hz. So and lastly, the Doppler effects is changes of wavelength and frequency of electromagnitude wave caused by motion of the target. Thank you.